And to be able to break a single job up into many tasks, it needs to understand the type of work that's being done in the job. Yarn can actually work as a generic distributed runtime, but in this course we'll be using it for running MapReduce jobs over data in Hadoop. In a MapReduce job, there are two distinct phases. Data is gathered in the map phase and then aggregated in the reduce phase. A mapper is a custom software component which you write, usually a Java class, although not so much in this course. And that component reads the source data from Hadoop and writes the parts that you're interested in back out to Hadoop. One instance of the mapper runs in a single task, and it reads from a single file block. In the example that we ran, the 660 megabyte source file was saved as 5 file blocks, so we had 5 mappers, one for each block. They each read a different part of the input, and they can all run concurrently, which is what gives Hadoop the ability to scale so well. The mapper extracts the data that it wants from the input and writes it as intermediate output to Hadoop. This first example is a variation of the classic word count program, which is the hello world of MapReduce. The input is in CSV format, and the map reads each line, splits it into fields, and writes out the value of one particular field, together with a counter, which is always written as 1, and we'll see why that is later in the course. When the map gets to the end of its file block, it completes, and the resources it was using are made available again to Yarn, which will allocate them to another task, if there are any more in the queue. When all the maps have completed, there is a complete set of intermediate output in Hadoop, which in this case contains all the classification values extracted by all the map tasks. Then Hadoop merges all those values. So if we had 3 instances of the string 6b4 in the input, Hadoop will merge them into one with a key of 6b4 and a value which is an array of all the matching values. The merged values get sorted, so 6b4 would be in a list between 6b3 and 6b5. This is called the shuffle phase, and when it's done, the sorted, merged list is used as the input for the reduce phase. The reducer is another custom software component, a Java class or a console app, which receives the merged, sorted data and aggregates it to get the final output that you want to see. Logically, the reducer works in the same way as the mapper, reading input from Hadoop line by line, where each line is a key value pair. In this case, I want a count of all the occurrences of each key, so the reducer simply adds together a value array that were originally written by the maps, when the processing is complete for the previous key, because the sorting of keys is a guarantee from Hadoop. So then the reducer can write out the final sum for the previous key. There's one more part to the MapReduce program, which is the driver. The driver is really just a setup component, which tells Hadoop which mapper and reducer to use, what file formats are expected, and the paths to the input and output data. Next, we'll look at the code in the mapper, reducer, and driver that we ran in the last demo. This is Java, but we're only going to use it to see how a MapReduce program is structured, so we won't be looking too closely at the Java API.